So this is section 2.2. In this section, we're going to talk about equations of lines. We're going to talk about identifying and calculating the slope. We want to identify parallel and perpendicular lines and how their slopes are related. We want to determine the equations of lines, so be able to write equations of lines. And then we're going to use our knowledge of linear equations to approximate solutions for word problems. So the first thing is we need to talk about slope. Is the steepness of a line as it rises or falls from left to right. So we always view slope reading it from left to right. And just as a note here, if we have something that looks like it's going up from left to right, then that would have a positive slope. But if it is going down from left to right, then we have a negative slope. Slope can be calculated with this equation of y2 minus y1 over x2 minus x1. The x1, y1, x2, y2, those are just arbitrary. But as long as we have the y's in the numerator and x in the denominator, we will be fine. And the corresponding x's and y's need to be together. So, whatever you choose your x2, y2 to be, if you want those to be first, then they have to be first for both the numerator and denominator. So to calculate the slope between 2 points, again, I just mentioned, but it's y2 minus y1 over x2 minus x1. And so we're going to calculate the slope for the number one here, the points 2, 4, and 5, 13. It's good habit to label your points just to keep everything organized. So I'm going to say that 2 and 4 are x1 and y1, and then 5 and 13 are x2 and y2. So I'm just going to substitute in to my slope equation. So I'm going to say 13 minus 4 is divided by 5 minus 2, which is 9 over 3, which then does have a value of 3. Okay, so now at this time, go ahead and pause the video for number 2 and try it out. And just a reminder that the origin is 0, 0. So go ahead and pause the video and calculate the slope for number 2. Okay, so assuming that you pause the video, I'm going to go ahead and go over this one. Again, it's good to label things just to keep everything organized. So replacing the values, I have 36 minus 0 divided by 24 minus 0, which is just 36 over 24. And this is not in a simplest form, and the Pearson homework wants it in simplest form. And personally, if there's any work that you have to turn in for me, like to hand in, I would want the slope to be in simplest form also. And you can find that in Desmos. If you type in 36 over 24, and then over to the left, there's a little button that has like a fraction inside of a circle. If you hit that, it will tell you that it's 3 over 2. We do like slopes to be in fractions, especially when it comes to graphing. When we get into predicting with slope, it's not such an issue that it's a decimal, but for graphing personally, we do like it to be in fractions when possible. There are some special cases with slope. A horizontal line, meaning a flat line, has a slope of 0. So looking at the example for a horizontal line, if I have my x2 or my x1, y1, x2, y2, so I have 8 minus 8 is divided by 12 minus 6. Then that comes out to being 0 over 6, which is 0. So that when I have a 0 in the numerator, so my y's didn't change. If you notice 8 and 8, right, those are the same. So my y's didn't change, so therefore I have a slope of 0. For a vertical line, so a line that's straight up and down, then we have an undefined slope. So what happens there? Say I have 15 minus 9 divided by 3 minus 3. 15 minus 9 is 6. 3 minus 3 is 0. So notice I have a 0 in the denominator. So then therefore that is undefined. Okay, so when you have a 0 in the denominator, that is not 0. Okay, that is undefined. If you plug in the calculator in Desmos, 6 over 0, it'll tell you it's undefined. If you plug it into a TI calculator, it will tell you, or it will give you an error. So those are a big difference between 0 and undefined, so please don't get those confused. So talking about parallel, perpendicular lines and their slopes. So parallel lines have the same slope, so regardless of what the y-intercept is, and the slope is whatever accompanies the x. So for the first two examples, it has a slope of 2 for both, so those are parallel. Perpendicular slopes are opposite reciprocals, which just is a fancy way to say that we change the sign and then flip the fraction. So as you can see, for the first one, we have a slope of 5 over 7. So in the second one, we have flipped the fraction and changed the sign to negative 7 over 5. So regardless of the y-intercepts, if the slopes are opposite fractions, or opposite signs, and flipped, then we can deem those to be perpendicular. And just as a reminder what parallel and perpendicular are, parallel are lines that go on and on forever that never cross. Perpendicular are lines that cross at a 90-degree angle. And to check to see if your slopes are perpendicular, there's a quick way to do that. You can multiply them together, and they should result in -1. So that's a quick way to check that your lines are perpendicular. And so now talking about equations of lines. So to determine the equation of a line, we just need a slope and 1 point. Then we can use the slope-intercept form. So if the slope is not directly given, then we may have to calculate the slope. But for our slope-intercept form, y is equal to mx plus b. M is the slope, and b is the y-intercept. Okay. So I already hinted at the slope on the previous slide, but the y-intercept is b. So for number 1, I have a slope of 3. So I'm going to say, well, that's y is equal to 3x plus b. So now I need to calculate b, which is the y-intercept. And last week we discussed how to calculate the y-intercept by plugging in 0 for x. Unfortunately, we don't have enough information to do that. But I do have a point that's x and y of 2 and 13, so I can plug those directly in. So I have 3 times 2 plus b. That gives me 6 plus b is equal to 13. And when I subtract that 6 off, I get b is equal to 7. So my equation for my line just replaces the b, and so I have plus 7. So before going to the next comment, go ahead and try number 2. You'll calculate the slope first and then plug it in just as we did with number 1. Okay, so assuming you paused the video and worked on number 2, I want to go over it. So I don't have a slope, so I need to calculate it. So I'm going to say that since it doesn't matter order, just for doing it, I'm going to say 12 is x1 and y1, and then x2, y2 for -5 and 8. It doesn't matter which way you did it. You're going to come out with the same result. So just to do something different. So I'm going to say 8 minus -9 divided by -5 minus 12. So 8 minus -9 is actually 8 plus 9 because minus a negative is positive. So that's 17 divided by -5 minus 12 is -17, which is -1. So I have a slope of -1. So now I can pick a point, and I'm going to use -5 and 8 to plug into my slope-intercept. So I have y is equal to -x from the -1 plus b. So now I'm going to say, well, 8 is equal to negative of -5. So be careful with the negatives, plus b. And so that's positive 5, so I subtract 5 over, so I get b is 3. So my equation is -x plus 3. And ultimately, what we want to be able to do is take these linear equations and be able to use it to approximate data. So the number of breweries, so this is our example problem, the number of breweries in the U.S. can be approximated by this given function or equation. And so x is equal to 7 would correspond to the year 2007. So we're talking about years removed from the year 2000. So first we want to find the approximate number of breweries for the years 2024 and 2030. Okay, so just for the first part here, I want to talk about 2024, but we're going to use x being equal to 24. Okay? And then for 2030, we would do the same as x is equal to 30. Okay? So what will happen, and y is equal to our number of breweries. So I'm going to substitute in for x into my equation. 24 minus 2459. And that's going to spit out a value for y if I plug that in the calculator. So all you need to plug in the calculator is 567 times 24 minus 2459. And you should get that there are 11,149 breweries in the year 2024. Do the same thing for the year 2030 when x is equal to 30. And plug that in the calculator and you'll get that there are 14,551 breweries in 2030. Approximately, and we're estimating because we don't know what the data says for 2030, of course, because we're not there yet. But that is the idea of taking these equations and being able to plug in some potential data and find maybe some more estimates on something that we're trying to approximate or understand further as the future may unfold. And for the second part here, what year were there approximately 6,500 breweries in the U.S.? Okay. So for this one, I'm going to say instead of solving for x, instead of solving for y, we want to solve for x because we have y. So it's 6,500 is equal to 567 times x minus 2,459. And I would solve this for x just the same as I would any other time. So then I get 8,959 is equal to 567x. And then divide by 567. And you'll find that x is approximately 16. It's like 15.8. Okay, so then what happens is, how do I interpret that? Well, then I would say in the year 2016, there were approximately 6,500 breweries in the United States. You can check this data to or check your result from the previous slide. In 2024 we had 11,000. In 2030 we had 14,000. right? So you wouldn't anticipate to get an answer of like 2027, right? You want to compare it to what the given data is to see if your answer is reasonable. Please, before you go into 2.3, check out the video I've posted to the As You Learn page, going over Desmos and how to calculate lines of best fit using the Desmos calculator. If you have any questions, please email me, and have a great rest of your day.